Hello everyone, welcome to this Leet Code challenge H index 2, and we have given a sorted array and we need to find that H index. And what the H index is, as per the definition you can see, n papers have at least H citation each, and other n minus H papers have no more H citation each. So let's go to the Wikipedia definition, and this is the definition, is the same as. So basically if I take a white paper and try to explain that, so so I think I have already done that. So this is what, so let's say for example you have a 5 publication called A, B, C, D, E, and we have the citation for each of the publications. So A for A we have 10 times, B for 8 times, C for 5 times, and D for 4 times, and E for 3 times. So what's the H index? So here H index, so basically what we are doing is we are indexing this. So A is 1, 2 is B, and 3 is C, D is 4, and 5 is E. Now as you see, as we are indexing it, right? So this is the first index which I cited 10 times. This is the second index which has been cited 8 times. This is the third index which has been cited 5 times. And this is the fourth index which has been cited 4 times. And suddenly we see this is the 5th index and it has been cited only 3 times. So basically it has been decreased, right? So the value, with this value, once it becomes equals, we can directly return the index position. So that's how. So it's a straightforward binary search problem, right? So let's say another problem. You have like 10, 8, 5, 3, 3. So now if you talk about the third citations has been 5 times, but fourth citation you see this is a 3 times. So if I just draw this, now this is the H index. So basically here H index will be 3 because we are going to return this index position is 3. Reason being, see this third index has been cited 5 times, but the fourth index has been cited 3 times. Basically it is a decrease, right? So that's how we need to find that H index. So let's go, and I've already done the coding and submitted once also. So let's talk about the solution part. Yeah, so this is the code which I have done. So basically what first I'm checking is if my citation length is 0, because there is no values at all. If I'm giving an empty value, I should return 0. And then we have a same old binary search problem, right? So we need to find the binary. Let's say the previous Leet code problem challenge was having find a position of a number where you can insert that number if you are not able to find in that array, or else return that index position. So this is how it is. So we have declared int low equal to 0, high equal to citation dot length, and low is less than equals to high. This is the normal binary search, and we are doing mid equal to low plus high by 2. But after that, what we are doing is if citation dot length minus mid equal to citations of mid. And what does that mean? So let me go to that whiteboard again. So you see this is a descending order array, right? So let me write down now in ascending order. So if I write down ascending order, it is 3, it is 4, it is 5, it is 8, and it is 10. Right? And now if you talk about mid position, this is the mid position, right? This is the mid position. And if you talk about an array index starts from 0, 1, 2, 3, and 4, right? This is the array indexing. Now let's say for example I want to find the real index, this index in the descending order. So how do I do that? So let's say for example if we have a 5 which has an index position of 2, right? Index position of 2, how do I find that? So basically 5 has an index position of 3. If you see here, 5 has an index position of 3, right? So total length, if you take about total length is 5, And if we reduce this value -2, we will get this index position in the descending order. And that's how we are going to compare. As soon as we find that index position which is greater than the citations, we are going to stop there and we are going to return that value. And that's the whole idea. And that's what I am doing here. So that's how I am doing here. So if you see citation length minus mid, which will give me the exact index positions equal to citation dot mid, citation of mid, that means that is the position where value is going to decrease. After that, value is going to decrease that because it's an ascending, this one, like the index is going to increase, but the value is going to decrease, right? So if citation, I am able to find that, so I'm just going to return that, right? And let's say, for example, citation dot return citation dot length minus mid. Basically, I'm returning the index position, and then if citation sub mid is greater than the same thing, like the same with the binary search problem, and I'm just going to go for high equal to mid -1, otherwise low equal to mid +1. And if you could have seen my previous video where we talked about finding that index position to insert an element in the array, we had a challenge, right? So here the low value we supposed to return, but this low value will give me the position where I can insert after or insert maybe like before, something like that, right? So we need to find that index position exactly, right? Now there are couple of limitations. So let's say, for example, if I am going to search for that and I'm going to return this value, but the problem with this is, what if low value is already reached to the high? Low is equal to high. In that scenario, this particular line will throw array index out of bound exception. So we need to check if low is already citation dot length. I'm just going to return citation dot length minus low. Otherwise, I'm going to return this, right? Otherwise, I'm just going to do this, right? And then basically, finally, we are just going to return that. So this is how I have done that. So let me submit. You see it has been accepted. And it's a 0 millisecond submission.